Cyclic codes are subclass of linear block codes. The advantages of cyclic codes are they have excellent mathematical structure which makes the design of error correcting codes with multiple error correction capability relatively easier. Encoding and decoding circuits for cyclic codes can be easily implemented using shift registers. Now we will formally define the cyclic codes. A linear block code is said to be cyclic code if any cyclic shift of a code word is also a code word. As we know, a linear block code will satisfy linearity property, which means that if you add any two code word, you will get another code word, right? Cyclic property says that if you make a cyclic shift to the code word, you will get another code word. Now, what is a cyclic shift? Let C be a cyclic code in an NK coding system with individual bits are represented as, say, C equal to C0, C1, etc. Cn minus 1. So, where C is one code word and C0, C1, etc. Cn minus 1 be the bits in that particular code word. When C is given a cyclic shift to right, the resulting code word is represented as, say, C of 1. That is, you are shifting the code word in this direction. So what happens? So you are shifting the code word in this direction cyclically. So that what happens? The Cn minus 1 will goes here. So C of 1 can be represented as C of n minus 1, C0, C1, etc. Cn minus 2. So similarly, C of 2 can be represented as, that is, you are giving two cyclic shift to right. That is, C of 2 is given by C of n minus 2, C of n minus 1, C0, etc. up to C of n minus 3. Now, interestingly, you can see that this C of 2, the starting bit will be C of n minus 2. Next bit will be C of n minus 1. Finally, the final bit is C of n minus 3. Now, proceeding in this manner, now what about C of k? So, we can see that for C of 2, this is C of n minus 2. Now, for C of k, we can write it as C of n minus k. The next bit is C of n minus 1. Right. So, this will be C of n minus k plus 1. This is C of n minus 2 plus 1. That is C of n minus 1. Similarly, here it is C of n minus k plus 1, etc. What about the last bit? This will be C of n minus k minus 1. So, this will be n minus 2 minus 1. That is n minus 3. Here it is n minus k minus 1. So, again proceeding in this manner. Now, what about C of n minus 1? That is n minus 1 cyclic shift to right is given by. Now, what will be the first bit? First bit will be C of n minus k shift is n minus k. So, n minus 1 shift is n minus 1, right? So, that will be equal to C of 1, C of 2, etc. C of n minus 1 minus 1. That is equal to C of 0. That is n cancel. Then C of 1 minus 1, that is C of 0. So here we can see that C of 1 is 1 cyclic shift to right, C of 2 is 2 cyclic shift to right, C of k is k cyclic shift to right. Now what happens if you give 1 cyclic shift to left? 1 cyclic shift to left. That is given by 1 cyclic shift to left will be you are moving or you are shifting the code word in this direction cyclically. So this will goes here. So that can be written as C of 1, C of 2, etc. C of n minus 1, C of 0. So this is C of n minus 1. So interestingly, we can see that n minus 1 cyclic shift to right is equivalent to 1 cyclic shift to left. Or generally we can say that k cyclic shift to right is equivalent to n minus k cyclic shift to left. To explain various algebraic properties and operations pertaining to cyclic codes, it is necessary to associate a code word of the cyclic code with a polynomial. So we know that our code word C is C0, C1, C2, etc. Cn minus 1. Now the code polynomial is represented as C of x. C of x is C0 plus C1x plus C2x square plus etc. Cn minus 1 x raised to n minus 1. Here the coefficients C0, C1, C2, etc. Cn minus 1 of the polynomial are the bits of the code word. Now we will illustrate the mathematical meaning for cyclic shift. Our code polynomial C of x is given by C0 plus C1x plus C2x square plus etc. Cn minus k x raised to n minus k plus etc. Cn minus 1 x raised to n minus 1. Now multiplying C of x by x raised to k, that is x raised to k C of x is given by C0 x raised to k, C1 x raised to k plus 1,
k minus 1,
C2 x raised to k plus 2 plus etc. Cn minus k x raised to n plus etc. Cn minus 1 x raised to n plus k minus 1, that is x raised to n minus 1 into x raised to k, that is. Now rearranging the terms of equation number 2 by writing from this term onwards, that is, this can be written as C of n minus k x raised to n plus C n minus k plus 1 x raised to n plus 1 plus etc. plus C n minus 1 x raised to n plus k minus 1 plus, then we will write from this term onwards, C0 x raised to k plus C1 x raised to k plus 1 plus etc. plus C. So what is the last term now? So the term just before this particular term, that is C n minus k minus 1 x raised to n minus 1. So this is equation number 3. Now again we are modifying equation number 3 as so I'm writing this term as C n minus k x raised to n plus 1. Now what does this indicate? That is, you are purposefully added C n minus k term here, and later we will subtract C n minus k term. Also we know that in modulo 2 addition is same as subtraction, right? That is, C n minus k minus C n minus k is equal to C n minus k plus C n minus k, which is equal to 0. That is, modulo 2 addition, subtraction is equivalent to addition. Okay. Now, how will you write the second term? Plus. So this I will put it in a box. Okay. Plus C n minus k plus 1 into x raised to n plus 1. That is, you have purposefully added additional term of C n minus k plus 1 into x plus etc. plus C n minus 1 x raised to k minus 1 x raised to n plus 1. That is, in this term you purposefully added the term C n minus 1 x raised to k minus 1 plus. Now we will add some terms for cancelling the identical additional terms deliberately introduced. So what are the deliberately introduced terms? C n minus k plus C n minus k plus 1 into x plus etc. C n minus 1 into x raised to k minus 1. So that is plus C n minus k plus C n minus k plus 1 into x plus etc. plus C n minus 1 x raised to k minus 1 plus our remaining terms, these terms, plus C0 x raised to k plus C1 x raised to k plus 1 plus c2 x raised to k plus 2 plus etc. plus cn minus k minus 1 x raised to n minus 1. That is all the terms up to cn minus k x raised to n. So that is cn minus k minus 1 x raised to n minus 1. So we can see that this the term, all the terms in this rectangular bracket are the terms used for cancelling identical additional terms deliberately introduced in the first rectangular bracket. So this is okay. So I will illustrate one more thing. We have cn minus k x raised to n plus 1 plus cn minus k is equal to, so I added this term for cancelling the additional term deliberately introduced here, right? So that is cn minus k into x raised to n plus 1 plus cn minus k is cn minus k x raised to n plus cn minus k plus cn minus k. So we know that this is modulo to addition. Addition of identical term will gives you 0. So this will be equal to cn minus k x raised to n. Now this is equation number 4. Now again rearranging equation number 4, that is x raised to k c of x can be written as, I am writing these two terms first, that is cn minus k plus cn minus k plus 1 x plus etc. plus cn minus 1 x raised to k minus 1 plus c0 x raised to k plus c1 x raised to k plus 1 plus etc. plus cn minus k minus 1 x raised to n minus 1 plus, then we will write this term cn minus k x raised to n plus 1 x raised to n plus 1 plus c n minus k plus 1 into x raised to n plus 1 plus etc. plus c n minus 1 x raised to k minus 1 into x raised to n plus 1. So this is equation number 5. So first bracket, second bracket. Okay. Now if you look at the coefficients of the polynomial in the first bracket, have you seen this polynomial somewhere else? So I just write the terms here, the coefficients here, c n minus k, c n minus k plus 1 etc. c n minus 1 c0 c1 etc. c n minus k minus 1. So you can see that c of k, that is by giving k cyclic shift to right, that is c of k is cn minus k, cn minus k plus 1 etc. c0 c1 etc. cn minus k minus 1. So this will be c of k, that is k cyclic shift to right. Now let q of x equal to, I am defining a new term, that is q of x equal to cn minus k plus cn minus k plus 1 x plus etc. plus cn minus 1 x raised to k minus 1. Now this equation 5 can be written as x raised to k c of x equal to, this is c of k plus q of x into x raised to n plus 1 ck of x. That is, we can see that ck of x is the remainder term obtained when we divide x raised to k c of x by x raised to n plus 1, and q of x is the quotient obtained. In another words, we can write it as ck of x is x raised to k c of x modulo x raised to n plus 1. That is, we can see that Modulo operation is basically the remainder operation. That is, ck of x is obtained as the remainder term if you divide x raised to k c of x by x raised to n plus 1. Now mathematically, what is ck of x? That is, k cyclic shift to right is the remainder term obtained by dividing x raised to k c of x by x raised to n plus 1. Thank you.